So notation is a little bit different, but hopefully you caught up and you figured this out. First one would be 5 times 4, which is the same thing as, sorry, 5 times 4 over 2 times 1. Simplify, and I believe you get 10. Okay. 3, it's 9, 8. So, sorry, let me write it. You got 9, 8, 7, 6, 5, and at the bottom you get 5, 4, 3, 2, 1. So the 5 goes away, the 4 and 2 simplify with 8, the 3 simplifies with 6 and becomes 2, and that becomes 126. 5, now 5 is a little longer, so 12, 20, C18, let's see if I can do this. 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. At the bottom, we're going to go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we can simplify this, right? So from 18 till 3 it will blow away. So let me simplify all that. And now I can simplify the 2 and the 20 becomes 10, and 10 times 19 is 190. 7. How many ways can a committee of 4 be chosen from 7 people? Okay, so here we have 7, 6, 5, 4, and then 4 times 3 times 2 times 1. Simplify 3 and 2, take away the 6, we get 35 different ways to select. Okay. 9. How many ways can a party of 6 children be chosen from a group of 10 if any child may be selected? If any child can be selected, that's our standard word, which is just that, simply. 10, 9, 8, 7, 6, 5 over 6 times 5 times 4 times 3 times 2 times 1. And again, I should be putting the multiplication signs. So we're going to get rid of the 6 and the 5, these two. 4 and the 2 gets rid of the 8, and the 3 and the 9 simplifies to 3. 10 times 7 is 70, times 3, 210. Oldest child must not be selected. So if the oldest child must not be selected, we are going to have 9 children. And we still want to make a committee or a party of 6. So that's 9 times 8 times 7 times 6 times 5 times 4 over 6 times 5 times 4 times 3 times 2 times 1. Let's see, the 6, 5, and 4. 6, 5, and 4 go away. The 2 and the 8 become a 4. The 3 and the 9 become a 3. 3 times 4 is 12. Times 7, we have 84 different parties. The youngest child must be selected. The youngest child must be selected. When we're completing the rest of the party, we're going to have 9 children to select for, because 1 is already, so the youngest is already chosen. So we have, instead of 10, we have 9. Instead of 6 children to be selected, we have 5, because the youngest already took a spot. So 9 times 8 times 7 times 6 times 5. 5 times 4 times 3 times 2 times 1. 5 and 5 goes away. 3 and 2 gets rid of 6. This becomes a 2, and that becomes 126. Again. If the youngest and the oldest must be selected, youngest and the oldest, right? So our party now, when you select 4, our party is now made up of 8 children. And we need to select the remaining 4, because 2 of the spots have already been taken. So 8 times 7 times 6 times 5, 4 times 3 times 2 times 1. So 2 and 3, get rid of the 6. The 4 and the 8 becomes 2. 5 times 7 is 35. Times 2, we have 70 different ways. Okay. 11, no, 13. From a set of 6 different coins, how many can 4 more coins be selected? Well, you got this one. Again, here is your clue. So we're going to have 3 different scenarios. So we have 6 coins. We can select 4. We have 6 coins. We can select 5. And then we got 6 coins. Select 6. Now from 6 coins and you're only selecting 4, this becomes 6, 5, 4, 3 over 4 times 3 times 2 times 1. Simplify, simplify. There's 15 ways for that scenario. Plus, the second scenario, we have 6 times 5 times 4 times 3 times 2 over 5 times 4 times 3 times 2 times 1. 5, 4, and 3. 5, 4, 3, and a 2. So there's 6 different ways. And the last one, if you have 6 coins, how many different ways can you collect 6? That's obviously just 1. So the answer is going to be 22. Okay. Find the number of different selections. 5 letters can be made from the letters of the word chemistry. Right? So chemistry has 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 9 letters, how many different ways can we select a party of 5? So we're going to go 9, 8, 7, 6, 5, 5, 4, 3, 2, 1. 5 and 5, the 4 and 2 gets rid of the 8, the 3 and 6 becomes 2, and then again this becomes 126. Must contain at least one vowel. Okay, so this one is one of the ones that we might want to think in the opposite selection. So we have 9 letters, right? If we take the letters E and I, we get 7 letters left over, right? So let's think about how many of them do not have a vowel. So if you're not to have a vowel, you're going to have 7, right? You pick from these 7 consonants and you make parties of 5. So it would be 7, 6, 5, 4, 3, and then 5 times 4 times 3 times 2 times 1. 5, 4, and 3 simplify. 5, 4, and 3 simplify. 2 and 6 become 3. We have 21 different ways, different combinations in here where there are no vowels. So 126 is a total minus 21, and this represents all the selections that had no vowels, no vowels, which means that if you subtract, I'm going to leave with 105, and 105 will have at least one vowel. Okay. How many different ways can a committee of 7 people selected from 4 men, 6 women? So there's 10 people in total. 4 of them are men, and 6 of them are women. So if the committee must have 4 women, we want 7 in total, right? So want a committee to have a total number of 7 people. To have 4 women, so let's do the math. If you have 4 women, it's going to be 6 women, and you got to pick 4, right? Which means from the men, you have 4 men, you're going to pick 2, right? That's one scenario. Okay, and then let me put that in parentheses. Plus, the other scenario is going to be, actually, let's multiply this. The other scenario is where you're going to have 6 women to choose from, and you're going to have 5 women in the committee, which means that from the men, we have 4 men, you only get to pick 1. And then for at least 4 women, and then we have the last scenario, which is 6 women to choose from, and you're going to pick all 6, which means the men, you're not going to pick any. Sorry, from the men, you're going to pick 1. So from the men, it's going to be, let me put this in parentheses, 4 men, and you pick 1 of them. Those are the 3 that you have to figure it out. So here, we get 4 times 3 over 2 times 1. That becomes 2, so that becomes 6 times. So from 6 women, you're going to pick 4, so it's going to be 6 times 5 times 4 times 3 3 over 4 times 3 times 2 times 1. That goes away, 2 and 6 become 3, and we have 15. So there's going to be 90, 90 in that first selection. Let me change colors. On the second scenario, from six women, you're going to pick 5, right? So this is a scenario where you have 4 women. This is a scenario where you have 5 women. And this is a scenario you have 6 women. So from here, let's do the men actually. Because I already, so, oops, sorry. This should be a 2. Because we got to pick 5 women, so that means I need to pick 2 men. And here, 6 women to pick 1 man. Good. No. Oh, I did this incorrectly. Stop. So the first scenario, if I pick 4 women, that means I have to pick 3 men. I apologize. So from the 4 men, I have to pick 3. So let's do that again. So this would be 4 times 3 times 2 over 3 times 2 times 1. 3, 2 goes away. I get a 4 times, and this is 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1. 4 goes away, 3 goes away, 2 and 6 becomes 3. We have 4 times 15. Better yet, we got 60. So there's 60 possible ways of doing that when there's 4 women. When there's 5 women, it's going to be 4 for the men, 4 total men. We got to pick 2 at a time, so we can get 4 times 3 over 2 times 1, and that's going to be 6 times, let me put that underneath, 6 times, and then from 6 women, I'm going to pick 5. We're going to get 6 times 5 times 4 times 3 times 2 over 5 times 4 times 3 times 2 times 1. 5, the 4, the 3, and the 2 go away, so there's 6 different ways. And 6 times 6 is 36, so let's add that. And the last scenario, from 6 women, I pick 6, so there's obviously just one way of doing that. And then for the men, 4 men, and I pick 1, so there's only going to be 4 different ways, so 4 times 1 is 4. If I add all that, I get 100. Okay. That's a nice little question. Alright, so determine if it's a permutation or combination. So permutation, maybe if you want to write that, order matters. I think of, I don't know, gold, silver. I call 3 people downstairs, or 3 people are called to go downstairs, and there's a gold medal, a silver medal, and a, what's the other one? Bronze medal. Right? First place, second place, third place. Combination. I send 3 kids downstairs. And it doesn't matter if it's A, B, and C to go downstairs, or I send B, A, and C. Yeah, it's the same 3 people going downstairs, or even C, A, B, right? All these are the same 3 students going downstairs. And imagine they're just going downstairs to help. So it doesn't matter in which order I call these 3 kids. They're all the same. So that would be a combination. Choosing the arrangement of 6 glass animals on a shelf. That is a, well, doesn't matter. If you think about 6 animals, I put the dog first, and then the cat, and then the elephant, and then the tiger, and then, I don't know, the squirrel, and then the bird. And then I switch the order. The cat comes first. Does order matter here? Yeah, so this is a permutation. Choosing 3 Chinese dishes from a menu. Well, this one is going to be a combination. Well, let's say you order, I don't know, beef and broccoli, chicken and broccoli, and another one, fish and broccoli. Right, so if you put this order, if you ask for this particular order, does it matter which one you call out first? At the end, when it's all ready, all 3 orders are the one you're going to take. Choosing 5 friends to invite to a birthday party. Well, think about it. You have 5 friends, A, B, C, D, E. They're all coming to the party. Okay, doesn't matter if you call A, B, C, D, E, or you send an invitation to B first, and A second, and C third, and E fourth, and D. This is a combination because it doesn't matter. Choosing a president, vice president, treasurer, or secretary. Right off the bat, this should be a permutation because the order does. Choosing two colors from a paint chart to blend together for the walls in your room. Let's see. Let's say you had blue and green, yellow, pink, purple. And you're going to choose two to blend for the walls, right? To blend together, to mix. So does it matter if you choose blue and green or green and blue? Or if you chose purple and pink or pink and purple? It doesn't matter, right? So this would be a combination. Choosing the order in which to watch 3 videotapes you rented for the video store. Well, order, that is your key word, right? So that one automatically makes that a permutation. 19. How many ways can a coach choose 6 starting players from a volleyball team of 13 players? Now, this would be a combination, right? If it's 6 volleyball players, right? If you put, remember, there's a volleyball, right? There's no first place, second place. There's not like it's different than baseball. I mean, I shouldn't even bring that up because if you don't understand, you need to understand the game. So this one, understand that in the volleyball, you select 6. The order doesn't matter. If I call this guy first or this guy first, they're still going to be playing. So it's a combination. How many ways can 4 textbooks be chosen from 8 textbooks in a locker? Right, so combination, it doesn't matter in which order you pick the 8 textbooks, you're still picking 4. Okay. You have 7 clean shirts in the laundry bags. How many ways can you fold 4 shirts and stack them in a drawer? Huh. Combination. Okay. Doesn't matter which shirt goes on top, and which shirts can second, and which shirts goes third or fourth. No. Right. So that would be a combination. 20. It's supposed to be only 20 odds. 23. Sorry. On her birthday, Yolanda brings cupcakes to school for her 28 classmates. On how many ways can she have cupcakes to the first 3 students returning from recess? Let's think. If you're at the door and you're coming back from lunch, and the first 3 people get a cupcake, does it matter in which order those 3 people come? So if A shows up, he gets a cupcake. B shows up second, he gets a cupcake, and C shows up third, he gets a cupcake. What if C comes first, and then A comes second, and B? Do each get a cupcake? What if B comes up first, C comes up second, and A comes up last? Do each get a cupcake? So order doesn't matter, right? So order doesn't matter. It's a combination. Okay. Wow, that was it. There's nothing else. All right. So